Okay, continuing with section 4.1. We have on the left-hand side examples that I'm going to do, and on the right-hand side very similar problems of homework problems you were going to do. Alright, number 1 and number 2. This is an order of operations sort of thing. And these two problems tend to cause some confusion. Well, usually everybody gets the first one right. The first one right, first one means, of course, to take negative 4 times negative 4, which is 16. Now the second one, some people will get it right, a lot of people will get it wrong. And it's an order of operations thing. And what I'll see a lot of times is students type this into their calculator, and the calculator will give them the answer of negative 16. And they will tell me, my calculator's broken, the answer should be positive 16. And my response is, your calculator is never broken. Okay? Here's what happens with this one. This is order of operations. In the order of operations, you have to remember what comes first. Powers or exponents? Powers and exponents are the same thing. Powers or minus signs. And the answer is powers come first. So this is really the same as that. What it's telling you to do, you do powers first, and the power only goes on the number 4. The power is not on the negative sign. So 4 squared is 16, and then you do the minus sign. That one really should be minus 16. Okay? A lot of people will tell me that one is 16. Minus 16 always. Alright, number 3. Number 3 is an easy one. Number 3, when the bases are the same, you add your exponents. So that's simply b to the 11. Add the powers there. Number 4, same thing. Once again, we add our powers. That gives us b to the negative 4. However, that will not be your final answer. The directions in this section will always say, write your answer using only positive exponents. What that means is, we have to write it that way. Remember our rule on negative exponents? If you have a negative exponent on top, it goes to the bottom. Number 5, kind of a combination of 3 and 4. We're multiplying. So what I do first is I multiply my numbers. Negative 4 times 6 is negative 24. And then I deal with my letters. B. I have a b to the negative 1 and a b cubed. I add my powers. Negative 1 plus 3 is 2. So that's b squared. And then with my c's, I add my powers. C squared, c to the negative 4. 2 plus negative 4 is negative 2. Then I notice that one of my things has a negative power. The one with the negative power goes on bottom. Everything else with a positive power stays on top. Now, a lot of people will want to drop the 24 to the bottom. The 24 does not drop to the bottom. 24 is just a negative number. The exponent on the 24, we're lazy, we don't write it, it's a 1. 24 has a positive exponent, it's 1. 24 stays on top. C has a negative exponent. C goes on bottom, and that's the only one. Alright, number 6. This time, instead of multiplying, we're dividing. So we're going to be subtracting powers. Negative 28 divided by 4 is negative 7. Then I have to subtract my powers. Alright, so I got to be careful here. I'm going to come off to the side. Negative 2 minus negative 3. That's negative 2 plus 3, which is 1. So the b has a positive power, which tells me the b goes on top. C's, on the other hand, I take negative 3 minus negative 1. That's negative 3 plus 1. That's negative 2. So I have two choices. I could write c to the negative 2 right there, or I can go ahead and do it in one step. Since the c had a negative power, the c goes on bottom, and it has a positive power. Alright, cruising right along here, going down to number 7. Number 7, what I see is I have a parenthesis here and an exponent outside. So the first thing I need to do is I need to probably get rid of that parenthesis, distribute that exponent through. So let's see, 2 to the 4th. 2 to the 4th happens to be 16. And then on the b, I have a power followed by another power. When I have a power followed by another power, I multiply those. So that's b to the negative 28. Same with the c's. Power followed by another power. That's c to the 16. Bottom, haven't touched yet. I'm just going to rewrite it. 5 to the negative 1, b squared, c to the 6. Alright, then what I see, I have the 16, but then this 5 here, this 5 has a negative power. Since 5 has a negative power, that tells me 5 is going to move up to the top. So I'm going to have 5 times 16. 5 times 16 happens to be 80. And then I look at my b's. I have negative 28 minus 2. Negative 28 minus 2 is negative 30. Since that's a negative power, it goes down the bottom, becomes positive. And then finally my c's. 16 minus 6 is 10, but that's positive. So that stays right on top, right where it is. Number 8. Again, I see that I have parentheses with a power outside, but this time I notice that the whole entire thing is covered by the parentheses, not just the numerator like it was in number 7. So I think what I would do, there's really two choices. Some people prefer to take this negative 3 and distribute it through to every single piece, and that's fine if you want to do it that way. Personally, what I prefer to do is I prefer to simplify inside parentheses first. After all, that's kind of what the order of operations tells you to do. The order of operations tells you inside parentheses first. Well, I've got a 2 and a 5. Those don't reduce. I can't do anything with those, so I just write them down. The b's, I've got a 1 minus a negative 1. That's 1 plus 1. That's 2. So b squared right there. The c's, on the other hand, I have a negative 7 minus negative 2. Oops. Minus signs there. That's negative 7 plus 2. That's negative 5. So since the c's have a negative power, they go on bottom. Then I have a power of negative 3. Alright, so now I'm going to distribute. That becomes 2 to the negative 3, b to the negative 6, I multiply my powers there, divided by 5 to the negative 3, c to the negative 15. Now, notice what happens. Everything on top has a negative power, so everything on top is going to go to the bottom, and conversely, everything that's on bottom has a negative power, so it's going to go to the top. So on top, I'm going to have 5 cubed. 5 cubed happens to be 125, c to the 15. And then on bottom, I'm going to have 2 cubed, which is 8. And then I'm going to have b to the 6th. Okay? So that one was complicated. That one's about as hard as the problems are going to get in this section. Okay, we have a few more problems. I'm going to flip the page here in just a second, and we'll take a look at scientific notation. Okay, we end 4.2 with what's one thing that these properties of exponents is good for? And the main thing properties of exponents is good for is something called scientific notation, which is a way of writing very big and very small numbers. So you've probably seen this before. 550, let's see, how would we read this number? This would be 5,300,000. We write this as 5.3 times 10 to the, and then we have to just count our decimal places. 1, 2, 3, 4, 5, 6. What multiplying by 10 to the 6 does, 10 to the 6 would move the decimal 6 places to the right. So, really big numbers you write, and they're going to have positive powers. On the other hand, really tiny numbers are going to have negative exponents. So we count 1, 2, 3, 4, 5 places we would have to move the decimal. So that one's a negative 5. Okay, so notice the way these are written. the first number right here is always between 1 and 10. So some people will write 62.43. Well, that's not quite scientific notation. Okay, the first number's got to be between 1 and 10. And then you simply count your decimal places. 1, 2, 3, 4, 5. So that's a negative 5. This one is a big number, so we count over 10 to the 6th. All right, going the other way, if I have a negative exponent, that tells me this is going to be a small decimal, so I got to move 4 places to the left. Well, in order to move 4 places to the left, there's 1. I'm going to have to move 3 more, which tells me I'm going to have 3 zeros and then a 3, 2. Conversely, this one has a big exponent, which tells me I'm going to move my decimal to the right. I'm going to have a big number. I got to move 8 places, so there's 2, which means I need 6 more, so I need 6 zeros. 4, 3, 6, 0, 0, 0, 0, 0, 0, 6 zeros. 1, 2, 3, 4, 5, 6. Alright, now scientific notation is used a lot by chemists and physicists and astronomers, people who are dealing with very large numbers and very small numbers. And the reason is it makes the arithmetic very easy. For example, these numbers are already given in scientific notation, and I can multiply them very easily. 3.1 times 3 is 9.3 times 10 to the, well, what we do is we add our powers. 10 to the 20. As simple as that. Alright, now how about these tiny little decimals here? Well, I'm going to write them in scientific notation. This one is 6 times 10 to the 1, 2, 3, 4, 5, negative 6, divided by 3 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, negative 11. 6 divided by 3 is 2, times 10 to the negative 6 minus negative 11, that's negative 6 plus 11, that's 5. That's 2 times 10 to the 5th. Okay, so scientific notation can make handling large numbers or small numbers very easy, especially when you have to multiply or divide.